So in order to do the free body diagram of the box, you're going to first start out with a dot to represent the box. Then you will indicate that there is a downward force of weight from the earth onto the box, and there's also friction that's forcing it downwards due to the wall, as you can see here. Then there's also a diagonal force with a normal force from a man who's pushing onto the box. And then lastly, there's a force from the wall onto the box, which would be normal. With a given diagonal line here, we have to find the triangle and their lengths. So this length here is given, which is 1500 newtons. Then in order to find this length, we have to use cosine 30 equals A over 1500 because that is the adjacent length. And then that will give you 1299 newtons. Then in order to find the opposite length, you have to plug in sine 30 and then equals O over 1500, and that will give you 750 newtons. We have to find the lengths of each arrow, so let's first start off with the sides. So since the sides have to be equal to one another, this side here, which we found with using SOHCAHTOA, equals 1299 newtons, which means that this arrow must equal 1299 newtons. Lastly, we have to find the lengths of this arrow and these ones. So the ups and the downs must equal one another. So we can see that 750 newtons is the top arrow. And so when we have the weight of the box, we have to transfer it from kilograms to newtons by multiplying it by 10. So we did 50 times 10 equals 500 newtons. So that would be this length here. And then the remainder would be 250 newtons in order to equal 750 newtons.